Hello people and welcome back to another video. In this session, we'll be continuing from where we left in our previous session when we discussed a sample problem on two sample t-test. Now in that problem, we solved a hypothesis testing scenario using the 5-step procedure, and we got the conclusion that our calculated test statistic was less than the critical value at zero point 0.1 significance level. Therefore, in this scenario, we can surmise that we do not have sufficient evidence to reject our null hypotheses. So in this particular session, we'll be looking at the confidence interval for a two-sided t-test and how do we calculate the confidence interval and surmise the result of our hypothesis test using the confidence interval. So previously, we have studied that confidence interval when confidence interval is given by estimate plus and minus margin of error. So in this case, the value of estimate for two sample t-test is going to be my difference in the sample means and my margin of error is going to be t critical into square root of s1 square upon n1 plus s2 square upon n2. This right here, this term s1 square upon n1 plus s2 square upon n2, this term is also referred to as standard error. So you can rewrite this equation as confidence interval is equal to estimate plus and minus critical t value into standard error. Okay. This will be a more recurring formula in our upcoming sessions. So we'll stick with this way of representing the confidence interval, as this will be extremely handy when we will discuss some concepts in the future. You will come to know very soon why, but for now, it's good if you remember both of these ways of representing. Actually, there is not much difference because margin of error is nothing but your critical value into standard error. But if you remember this, then it will be a lot easier for you to follow the upcoming sessions. So now let's go back to the problem at hand, the problem that we discussed previously. We had two samples of polyester strips, one buried for 2 weeks, the other buried for 16 weeks. We calculated all the necessary values. We did the 5-step procedure of hypothesis testing, and we surmised the results at the end. Now, using what we have already, let's calculate the confidence interval. Going back to R, I'll calculate my estimate, x1 bar minus x2 bar. I got my estimate. Now my T critical value in this case, now previously when I calculated my T critical value, I calculated it on the basis of the fact that it is a one-sided t-test. But now, here I need to calculate the confidence interval. And as discussed in multiple previous sessions on confidence interval is always two-sided. Because when you are calculating the confidence interval, you are calculating the lower bound and the upper bound. And when calculating confidence interval at 0.10 significance level, the area between the two lower bound and the upper bound, this is zero point 0.9. Let me just redraw it once again. I'll take out all the previous details. And I'm calculating confidence interval between 2 points, lower bound and upper bound. This is going to be the area in between. Point 0.9. And if I need to calculate this P critical value out here, so because of the property of symmetry of T distribution, the area to the left of lower bound is equal to the area to the right of upper bound. And because these two areas are equal, this area is equal to this area, zero point 0.05 and 0.05. So the area towards the left of upper bound is 0.9 plus 0.05, that is 0.95. So to calculate T critical for this case, I'll take it as TCL is equal to, this time I'll take 0.95. In the last question, when we were calculating using our 5-step procedure, we took it as 0.9 because it was one-sided. Here, because we are calculating confidence interval and confidence interval is always two-sided, we are taking 0.95, and my degree of freedom is going to be the same, n1 minus 1 comma n2 minus. Now this comes out to be 2.131. So my TCL is 2.131, and finally my standard error to calculate my standard error, I'll write it completely like this. I have square root of s1 square upon n1 plus s2 square upon n2. Okay, perfect. Now I'll calculate my lower bound and my upper bound. So lower bound is going to be estimate minus TCL times standard error. So lower bound is minus 8.553, upper bound is 25.35. So I can say that for this particular question, my confidence interval lies between two values, minus 8.56 to 23.35. Now What was my null hypothesis, or the condition that I started with, that the difference between the population means of the two populations is equal to 0. Now, this is the confidence interval that I'm getting for the population parameter. And you can see that here, the initial the initial value of my difference, that was 0. 0 lies in between these two, upper bound and lower bound. And because my value that I've chosen at null hypothesis, it lies in the range of the lower bound and the upper bound of the confidence interval, we can clearly state that we do not have enough evidence to reject the null hypothesis, because my point lies in between the lower bound and the upper bound and not beyond them. This was the juxtaposition of confidence interval into the larger concept of hypothesis testing in a two sample t-test. I hope you all enjoyed this session. I will see all of you all in the next session. And also, this concludes our discussion on two sample t-test. Thank you.